Now see this question. If lambda 1, lambda 2, lambda 3, so on lambda n are the eigenvalues of a matrix A, then we have to show that k into lambda 1, k into lambda 2, so on k into lambda n are the eigenvalues of k into A. So what they wanted us to show is this one. Let us say you have a matrix like this, something like this, A, B, C, D, okay, something like this, and now you found out that the eigenvalues of this matrix are 1, 2, okay, and now if you multiply this matrix with a constant, then the eigenvalues for the resulting matrix will be a scalar multiplication of the eigenvalues for the original matrix. So what they mean to say is, if you have a constant 2 and if you multiply this matrix with that, which means if you are talking about the matrix 2A, 2B, 2C, 2D, then what they wanted to show us, what they are asking us is to prove that if these 1 and 2 are the eigenvalues of this matrix, then you have to multiply this one with 2, which means 2 and 4. Then 2 and 4 will be the eigenvalues of this matrix. Are you getting this? Simple. If a matrix is given and if you are able to find out the eigenvalues, then if you multiply the matrix with a scalar, then the resulting matrix, whatever you get, the eigenvalues for that one are nothing but the scalar multiplication of the eigenvalues of the original matrix. Here, if you find out that the eigenvalues of this matrix are 1 and 2, then they are asking us to show that if you multiply the matrix with 2, then if you multiply this eigenvalues also with 2, then these eigenvalues, these values will become the eigenvalues for this matrix. That is what they are asking us to show. Okay, now let's see how to find it out. So they are using a constant k, right? So if lambda 1, lambda 2, so on lambda n are eigenvalues of matrix A, then we have to show that k into lambda 1, k into lambda 2, k into lambda n are eigenvalues of k into A. This is what we are supposed to show. Now there are two cases. One case is if k equal to 0, and other case is k is not equal to 0, right? So why am I distinguishing these two cases? You will understand it. So case 1, let's talk about when k is going to be 0. When k is going to be 0, then k into A is obviously going to be a null matrix, and we know that the eigenvalues of the null matrix are all zeros. Therefore k into lambda 1, k into lambda 2, so on are all going to be zeros, and so they are going to be eigenvalues of the null matrix, and so it is true when k equal to 0. What is true? If lambda 1, lambda 2, so on lambda n are eigenvalues of A, then k into lambda 1, k into lambda 2, so on k into lambda n are eigenvalues of k into A. This is true for lambda equal to 0. Now we have to show that this is true for lambda not equal to 0. Now let's go to the second case. Second case is what? If lambda is not equal to 0. Now let's see how to prove it. Instead of proving it directly, I want to prove it in the backward manner, which means they have already given that lambda 1, lambda 2, so on lambda n are the eigenvalues of A, which means A minus lambda I equal to 0, determinant of A minus lambda I equal to 0 is the characteristic equation for the matrix A, and this equation will be satisfied by all the lambda equal to lambda 1, lambda 2, so on lambda n, isn't it? This will be satisfied. Now both sides I'll be multiplying with k power n. We already know that k is not 0, right? Therefore here I am multiplying with k power n, both sides I am multiplying with k power n. Then what I do is, I think you already know this rule, k into A determinant equal to k power n into A, where A is a n by n matrix. If A is a n by n matrix, if you want to pull out this constant out of this determinant, then you have to multiply with k power n. This one we already know it. I am just going to use it. Simple. I have written this characteristic equation which is true, and from this characteristic equation I am multiplying both sides with k power n, and using this rule I am just taking k inside. Okay, so this one is nothing but I can take k inside and I can write it like this, and then I am expanding it, which means I am multiplying both A and lambda I with k. Then what do I get? Ka minus k lambda I equal to 0, which means again this equation will be satisfied for lambda equal to lambda 1, lambda 2, so on lambda n. Getting this? So what does it mean? If this characteristic equation is going to be satisfied, it is nothing but K into A is a matrix for which K into lambda is nothing but the eigenvalues, right? And what is the value of lambda? Lambda can be lambda 1, lambda 2, so on lambda n. Therefore K into lambda 1, K into lambda 2, K into lambda n, so on K into lambda n is nothing but the eigenvalues, right? So why is it useful? See this, if you have some values like this 1000, 2000, 3000, 4000, if they want you to find out the eigenvalues for this, how can you find out the eigenvalues? Just you divide it with 1 by 1000, then it is nothing but 1 2 3 4, right? You find out the eigenvalues for this matrix and then multiply this with 1000, whatever eigenvalues you get, you will get the actual eigenvalues for this one, right? Scaling down and scaling up will be easy. It is simple. I hope you got it. So even if you are not able to remember the proof, just remember the statement. What is the statement? You can find out the eigenvalues for a smaller matrix, right, like this, and then you can scale it up to even a bigger matrix. Simple, right? Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkey's ranking is 400. If you are happy to get into IIT Roorkey, then getting into universities better than IIT Roorkey is easier compared to getting into IIT Roorkey. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.